I'm going to do 24 now. I skipped a few questions which either I thought was very easy or we've done in class. So 24, calculate the mass of butane gas. Question asks for mass of C4H10 that would be needed to heat 724 ml of water. So V of H2O is 724 ml from an initial temperature of 7.44 to 50.7, and you are given the thermochemical equation for the combustion of butane. Okay, we are going to start on the water side. If you just consider the water, then you essentially need to work out, first of all, if I want to heat this much water from this temperature to this temperature, how much energy is needed. So essentially, I need to start by calculating the energy that needs to be absorbed by water based on the information given to me. And in order to find energy absorbed by water, I am going to use E equal to mc delta T, since that's the only formula that I have that will determine energy absorbed based on a change in temperature. So because the initial temperature is 7.44, final is 50.7, change in temperature is this. So 7.50.7 minus 7.44, 43.26 Celsius degree is the change in temperature. I'm going to do the same thing I did with a previous question and actually use the density of water from the data book, which is 0.997 grams for every mil, and that is equivalent to mass over 724 mil. So the mass of water, the mass of 724 ml of water is going to be 0.997 over 1 times 724. 0.997 times 724 is 721.828. I'm just going to use all the grams. Okay, so from here we can find the energy absorbed by the water. So E absorbed by H2O. Not sure why I close the bracket there. Absorbed by H2O is going to be mc delta T, which is 721.828 times 4.18 times 43.26. Okay, 43.26. So 130,525.874, and the unit is going to be joules because once again specific capacity is in joules. I'm going to go ahead and convert it to kilojoules because if you look at the thermochemical equation, that is in kilojoules. So at one point very soon, you're going to have to do a conversion before you can compare the two ratios. So this is in kilojoules. Now, the crucial thing that we are assuming here is we're assuming this is going to be equal to the energy release by butane. Obviously, if you need this much energy to be absorbed by water, then the least amount of energy that's released is this. So from here, I'm going to go with, in order to find the mass, I think I'm going to need to find the number of mole first. I don't think I'm going to have enough room. Maybe we can go try. All right, let's see. Okay, so from the equation, you would have a ratio between E released and the number of mole as shown in the coefficient. So it will go with number of mole first because that's what we need to find. The number of mole that is going to release 130.525 kilojoules of energy is going to be equal to 2 mole for every 5,748 kilojoules of energy. and the 2 is from the equation, and the 5,748 kilojoules is also from the equation. You should be able to find the number of moles C4H10 just by rearranging the equation. And this is the main reason why I flipped the ratio, which is the reciprocal of what you normally see, because I want the unknown to be on the numerator to make it easier to transpose. You can definitely have it on the denominator. It doesn't change the equation, it just makes it a little bit harder to transpose, especially if you're not very confident with that. So we have 0.0454 mole. And finally, I'm going to find the mass of C4H10, which is going to be number of mole times molar mass. So times 58, I think it will go into 3 sig fig is going to be 2.63 grams, and that's going to be my final answer for example 24, which hopefully is not too difficult.